Hello, everyone, and welcome to Global Hack Week. Glad to have you here. Today's session, we're going to be talking about turning food reviews into art using sentiment analysis. Welcome to Global Hack Week. If this is your first session, we're talking about all things data this week. And I hope you've been having a great time so far and are excited to continue hacking throughout Global Hack Week and learning a lot. I know I'll be learning a lot from the other coaches as well. All right, so let's just dive in. A quick introduction. My name is Gabriella. I'm a coach here at Major League Hacking. Some other fun facts about me is that I'm currently addicted to rug tufting. If you're unfamiliar, rug tufting is a type of craft where you either use a punch needle or a rug tufting gun to essentially make rugs. Kind of completely unrelated to tech, but a fun fact and more related to today's session. I love an aimless long walk, bookended by trying new restaurants, and I love leaving reviews for restaurants. Not usually on Google Reviews, which is what we'll be using today for our sentiment analysis, but I still love reviewing food nonetheless. Glad to see we have some people in the chat. Hello to everyone who's new. If you weren't here right when the stream started, I dropped the link for check-in, and that'll be up on the screen as well right now for you to check in. I'll give you a few minutes to check in with MLH. This allows us to track your attendance at the different streams throughout the week and allow you to be potentially eligible for swag or other exciting surprises as a part of Global Hack Week. We have someone who is passionate about sentiment analysis. Glad to hear it. Today we'll be going through a brief introduction to sentiment analysis. Among some other things, I'll dive into the agenda in just a second. If anyone has any questions, feel free to drop them in the chat. I'll give y'all a few seconds to check in to the event. The link is just up on the screen, and if you have any questions, drop them down below. We'll get started in just a few. Gotta get some water. Okay. I hope that was enough time for y'all to get checked in, but no worries if not. It's in the Discord, and I'll be showing it at the end of today's presentation as well. So here's a little bit of an agenda walkthrough of what we'll be doing today. The slides aren't too long. We'll just be doing a basic intro to sentiment analysis, a little bit about what sentiment analysis is, and kind of the technology behind it. We'll be doing a very basic implementation where we're using a predefined sentiment analysis model from Hugging Face. If y'all are unfamiliar, Hugging Face is a very popular machine learning library that's used with Python, and you're able to implement it very fast. You can create your own account to work on more advanced models, which we will be doing in the second part of this, is we're going to be gathering some food reviews and building our own sentiment analysis model. This will be done through Hugging Face as well. And we luckily already have a large data set that I found before this stream, so we won't have to go through and scrape those food reviews or manually find those food reviews. That'd be very time consuming. We don't have time for that today. Third, what we're going to do is we're going to do some gradient matching to our sentiment analysis. So kind of where the art part comes in for today's stream is that we're going to create a gradient between two different colors, and then we are going to match that to our sentiment analysis. So every time our model makes a prediction of if a review is positive or negative, we're going to do just like a binary sentiment analysis for this stream. It gives us a percentage of like how accurate it is. It's usually within the 90s. If it's a less accurate model, it'll be lower than that. But we'll be using a version of that number to create like a gradient overlay on different images we find in the food reviews. Oh, it looks like someone cannot hear me. It looks like on my end, on the StreamYard end, the audio is working. Is anyone else not able to hear? Okay. The master says that they're able to hear. So Tammy, I just recommend maybe leaving the stream and then rejoining, maybe restarting your computer, and you can be able to hear me then. Okay. So to continue on like an overview of what we'll be doing for, oh, awesome, you can hear. We'll just be doing gradient matching with the percentage of accuracy of our sentiment analysis and overlaying that on different food review images. And if we have enough time, we might put them all onto like a fun formatted HTML page. That might be a little bit ambitious for our 2-hour time slot, but that's kind of a basic overview of what we'll be doing. Any questions so far? Feel free to drop them in the chat. Right now when the slides are up, I'll be able to see y'all's questions very easily. But once we move over to coding, I'll be moving back and forth and won't be as quick to respond just because I'll be focusing on the code a little bit more. Okay, so here is a pretty basic example of what sentiment analysis is. Very binary, kind of like true, false, positive, negative sentiment analysis. So 1 in this case represents true or positive. So we have some examples of positive sentiment analysis, statements like good job, I love your hair, sick nails, this pizza is divine. I provided some images of positive things, like of positive examples for a sentiment analysis model. And for 0 or false in our sentiment analysis, or negative, we have some statements like this pizza tastes like cardboard. That would be a negative food review. I don't know anyone who wants their pizza to taste like cardboard or says that in a positive manner. Or if someone says your shoes have seen better days, your cuticles need some love, they have a picture of some moldy cheese as well as a failing test for some negative images for a sentiment analysis model. We'll be just working on a sentiment analysis on text, but with like there's more complex models you're able to do with sentiment analysis that are not just based off of text, but also things like the contents of a video or like positive, negative otherwise. All right, so here's a little bit of the technical jargon of what sentiment analysis is. Now that I kind of provided a basic explanation of what sentiment analysis is as a concept, now I'm going to dive into kind of like what sentiment analysis is in machine learning and how we're going to actually be applying it. So sentiment analysis is a part of NLP, which if you are unfamiliar, NLP stands for natural language processing. That recognizes the polarity of a text. And basically what that means is kind of the meaning or like the meaning, the sentiment of like the overall text. There's a lot of ways to do that, a lot of different ways within NLP that you're able to break down like what people mean in text and kind of like the overall sentiment. But the standard is pretty much good, like meh, bad. The very basic one that we'll be doing today is just good, bad. There are sentiment analysis models that can go into whether or not they liked something a lot, something they disliked something a lot, or they felt neutral about it, or they liked it a moderate amount, or disliked it a moderate amount. Kind of going into like a more of a range of good, neutral, and bad, as well as getting into more specific inputs in the text, specifically for like the application, which kind of brings us to our next point. Sentiment analysis is usually used as a way to gauge how a product or service is doing in the market. So for example, marketing teams for different products or different companies will put out sentiment analysis on things like Twitter, Instagram, Reddit, other social media sites to see the public opinion of how it's doing. Sometimes this is also done just in like a more basic way on the reviews on like the company's website itself. That's kind of like a very basic application of sentiment analysis, and it's done pretty widely. But also sentiment analysis is done in a more complex way to gauge like the public's opinion on more abstract ideas. So that can be political issues, current events, as well as how people feel about like a new local proposition that might be like through local politics, but not something you like might think of as inherently political. Something like how do the local residents feel about repaving a road, or in more rural areas, paving a road that used to be gravel? How do like people in a certain district feel about adding more funding to different areas? Things that like you aren't necessarily thinking about doing research on when you're doing research on politics, but like are relevant, and that can be done if I guess it's a larger district or a city itself. As I guess very small populations, it would be difficult to do sentiment analysis on, just because there isn't like a ton of data, which makes the model less accurate. We'll kind of talk about that once we get started coding in a little bit. That's kind of the basics behind sentiment analysis. Do we have any questions so far? I want to make sure that everyone understands sentiment analysis and kind of the basics of what I just said before we get started coding. I'll give y'all a minute if you want to ask any questions. Hello. We have someone joining from Algeria, Shaima, I think. Glad to see you're here. Yeah. Cool. All right. If we don't have any questions on what I just covered, we can dive into coding. So I have a bit.ly link up above. This is going to lead you to a GitHub repository where I have some basic key tools for what we'll be doing today. But if you don't have time or frankly just don't want to clone this repository right now, don't worry. I'll have a bit.ly link at the end as well, where you can see the slides and look at the finished code at the end of the stream. All right. I'll give y'all a minute to get that link. Tammy likes the slide designs. Thank you. I can't take credit for them. They're from Canva. Yeah. All right. I'm going to move over off of the slides and onto code. So, we have one question. A quick recap of what we're going to learn today. We're just going to do some basic sentiment analysis, and we're going to be doing it on food reviews. One of my favorite pizza places. Yeah, and then we'll also be applying the sentiment analysis prediction numbers to a gradient that we're going to overlay on different images that we find in our food reviews to kind of create art that is unique to the sentiment we get. All right, so I'm just going to be using code spaces, which if you're unfamiliar is a browser version of Visual Studio Code. You can clone your repositories. So I'm just going to clone my repository right now. I'm going to close out of Copilot. We don't need it right now. And then we're going to open up our README. This is a kind of basic walkthrough of everything we'll be doing today. And then we have our, just walk through. Okay. There's a few basic installations I need to do just because I'm in code spaces instead of my local Visual Studio Code. So if we have to do that, that's okay. Okay, so just kind of like a basic walkthrough of the files that you'll find in the GitHub repository. We have this IPython file, which we're not going to touch for right now. This is where we're going to be building our own model. That's the second part of what we'll be doing today. And below that, we have our index.html file. This is where I built out a basic, or not built out. This is from Geeks for Geeks, a built out gradient overlay that we're going to be customizing for our images of pizza from the food reviews. We have a README file, which has an overview of what we're going to be doing today. So some basic sentiment analysis, implementation with a pre-made model and Hugging Face, just kind of show you how it works at a basic level. And then we're going to be building a review-specific sentiment analysis model. So this sentiment analysis model is going to be trained on actual food reviews, which I found a food review data set on Kaggle. If you're unfamiliar, Kaggle is a great resource for machine learning and data science that has lots of different information data sets on almost anything you can imagine. This one is pretty old, but because restaurant reviews haven't really changed a ton in the past 8 years, I would say, it's still pretty accurate. It's a relatively small data set with, let's see, only a little bit under 1,000 lines of restaurant reviews. They're pretty short, but it'll get us kind of the basic gist of what we need for this simple implementation today. Some stretch, we'll be turning everything into a gradient. And then I have the resources at the bottom, which is where you'll find the links to everything. Yeah, we have a tutorial I followed on Hugging Face to walk through some of this, and then sentiment analysis and some slides in the stream. Okay. And then here we have our restaurant reviews. These are from the Kaggle. It's in a .tsv file, which is a older data file, and a lot of Python currently uses CSV for its data. So I converted it into a CSV file just for ease, and I'll walk you through how I did that. But now that we're all familiar with that, we can get started with our test.python file. This is where we're going to go through a very basic implementation of sentiment analysis so that you're able to kind of see how sentiment analysis works at a basic level, how you can implement Hugging Face's built-in sentiment analysis model before we build our own. And we're also going to be using food reviews. So I think the first thing I'm actually going to have us do is I'm going to go over to Google. And as you can see, I've Googled Bleecker Street Pizza. It's a very popular pizza place in New York. One of my favorites. Great cheese pizza. And that's the only thing I ever get at most pizza places, to be honest. Here's an image. That's not what I need right now. But we have our reviews. I wonder if I can... I'll just say like this. Okay, so we have this negative review, or like moderate review. They left 3 stars. It looks like the pepperoni pizza was not fully cooked. And they had some changes, but they liked the staff. So that's a negative review. And I'm just going to start pasting these in so we can do our sentiment analysis on some basic reviews. So here we have our first one, and I'm just going to do Bleecker Street reviews. And then we're going to put these into an array, list, whatever you like to call it. And then I think we're going to find maybe 5 to 10. I feel like that will give us a good sample size. Here we have another relatively, I guess it's a medium-sized review, and it's a very positive one, 5 stars. They tried the Nona, and they liked it. Okay, second review. I'm going to just put all of these on new lines to make it a little bit easier to read. It will be a very long array, but that's okay. Okay, and then here we have a relatively positive one. I'm not going to read the entirety of all of the reviews just because they tend to be a little bit long. When I leave reviews, they're never this long. Okay, and then it's loading. Let's get some low reviews, just some like 1 star. Just okay pizza, nothing special, overpriced cheese slice for $80 or $4.80. Yeah. Looks like this person did not like Bleecker Street. So we'll put this one in here for some variety. I'm going to do one more negative one. Okay. Cool. Okay, and then let's do some more positive ones. Because I think we had 1 positive, 1 middle of the road, and then 2 negatives. Okay. They liked the Nona. Maybe I need to try the Nona instead of only just getting cheese every time I go in. Okay, and then 1 more. We'll do Jennifer's. She thinks that Bleecker Street Pizza is a New York classic. She was visiting and stopped in. Sounds like she enjoyed it. Okay, so we have, I think 5, maybe 6 reviews. Honestly, we can just see. I'm going to comment out these. And then beautiful. Okay, we have 7 reviews, so that's plenty. Okay. before we go any further, I am going to have a 2-second intermission, just because my laptop needs to be plugged in and my charger is just out of frame. So I'll be right back. All right, hello again from the world's shortest intermission. We're all plugged in, so all good to go. Okay, so we have our 7 different reviews. Let's clear this out. Okay, so to get started, we're going to import some different libraries from Hugging Face and relevant to Hugging Face for our sentiment analysis. Sorry, my mouse is frozen. Okay, so now we're back. We're going to import these transformers and pipeline, and I'm just going to run this to make sure those libraries are working, and it looks like they're not, just because this is a code space, so I think like those libraries just haven't been installed with pip. So I'm going to do pip install transformers. Okay. I don't really want to make a virtual environment. I'm going to let it use high fidelity fonts. We don't need to make a virtual environment because we're in a code space. So this is all going to go away at the end of the stream anyway. Little water break while we're installing things. Looks like pip needs to be upgraded and code spaces. Sure, we'll do that as well. Okay, we're going to run this again, see if all our packages were successfully installed. It's thinking for a long time, so I'm getting skeptical. As always, if you have any questions, feel free to drop them in the chat. I will answer them. Okay. I don't know why it's thinking for so long. Let me close out of this, rerun this. Might be because of pipeline and torch. I also need to install those, but we will let this think. Here we go. Okay, everything is properly installed. So the next step, now that we have these libraries installed, is pretty simple. So we're going to do some basic sentiment analysis by adding in a sentiment pipeline from our transformer pipeline library. And we're just going to do this by typing out sentiment analysis, and we're going to set that equal to our pipeline library. And then I believe the library is called Sentiment Analysis. Let me double check. Yeah. Okay. So our food reviews right here from Bleecker Street are going to be our basic kind of like information that we're running everything on, and our basic like what we're running for this model, and we just like want to see the result of everything, um, which is already like it's been trained in the sentiment analysis from the pipeline library. So instead of printing the link, we're just going to comment this out. And what we need to do is just basically create a result of what we are running. And we'll do that by typing out result. We're going to call the sentiment pipeline of what we just typed out. So sentiment pipeline. I named it sentiment analysis. It should be sentiment pipeline just because it's going to get confusing if we have two sentiment analysis, because the library is often called that. So sentiment pipeline, and what we're going to call on it is our Bleecker Street reviews, and then we're going to print the result. It's pretty simple. This is all there is to the basic sentiment analysis, and I'll talk you through the results in just a second. So it's running. Okay, so all of this it's spitting out is basically because we did not specify specific information for our model. We just use like a basic pipeline of sentiment analysis. We didn't type out accuracy, bias, all of that more, I guess for like more robust and accurate sentiment analysis model, you're going to want to include that. Or when you're using a model from Hugging Face itself, it will have more of that. But here we have it just configuring it. It is creating the model with safe tensors. It is tokenizing all of our information and taking in our vocab.txt, which it does based off of the model as well as the input test information we're giving to it. And this device is set to use CPU, which is related to how it trains the model, and kind of like how quickly it's able to run it. Okay, so here we have our information. I'm going to copy this just into our README file. Because it'll be a little bit easier for me to read. So here we have our first review, and I will pop these up next to each other so we're able to kind of see everything back to back, and then put down this. So for our first review, we had the one where they didn't like the pizza, but they liked the service. And they gave this a negative, the model gave it a negative label, and it is 97.5% sure, but it is negative. It was a 3-star review, but it did have like a lot of negative words in the review. So this makes sense. And then we have our next review. They tried the Nona. They really liked it. This was, I think, one of the 5-star reviews. Here we get positive, and it has a 99.6 or 99.9%, 99.9% likely that it is positive according to the model, which I would say is accurate because they gave it a 5-star. They relate to the Nona and the overall restaurant environment as well. And then here we have let's see if this is 1 or 2. Yeah, okay, that's one review. So right here, they said that you can visit Euphoria if you choose to. It's a flavorful punch of a slice, well positioned among the hierarchy of New York pizzerias. I would say that that's a positive review. Didn't read the entire thing, but um, it's pretty positive in the first few sentences. And the model labeled it positive with a score of 99.7. So pretty sure that it's going to be positive, and that's what the data that we're seeing manually is saying as well. And then for our next review was one of um, the negative section. Just okay pizza, nothing special. Said it was overpriced, little no sauce, and thought the restaurant was dirty. Um, so I would say negative review right there. Negative is what the model said, and it was 99.8% sure. Um, Next one, garlic knots are good, but did not like um, how the customer service was. So they gave it a negative review. The model said it was negative and was 99.8% sure. And then here we have our second to last one, best pizza in New York. You need to stop by if you're in Manhattan. Positive review, in my opinion. And then it said positive over here with a score of 99.9. So very sure it is positive. And for the last one, we have a negative review, which I got that one from the positive section. So I'm curious to see the entire review if there's maybe some negative words in it that I didn't notice before. But it only has a 71.6% confidence level that it is negative. So we have Bleecker Street is a New York classic, visiting town and stopped in. Guys are friendly, offer few modifications. Okay, but they're saying it's not great if you have a picky friend, plenty of room, you might wait. Workers are good wiping down in between, and then they sell drinks as well. So it looks like it was a relatively positive review. They left a 5-star, but this just shows that with a model like where we don't dictate everything, it's not going to be perfect. And it was also a little bit unsure on this rating. So I guess it makes sense that it ranked it negative because it was unsure of that, and maybe some of the words were negative, or talking about how it might not be perfect for some of your friends. Okay. Cool. So that's kind of the basic first part of a sentiment analysis implementation. Very simple. You're able to kind of see some sentiment analysis without building out an entire model, and with some basic Python skills. It looks like we have some questions. I'm going to go through and answer them. Okay. If someone doesn't have any programming skills and wants to build something like this and get coding challenges done, you recommend to do or use? I would just recommend following the streams in Global Hack Week, and looking through like the different GitHub repositories and handouts that coaches give. I feel like it's a great way to learn throughout this week. And also in the Discord, there's lots of knowledgeable people who are able to answer your questions. Okay. And then Tammy has a question. How do embeddings or transformer-based models improve sentiment analysis compared to simple word counts? Thank you. I would say that they kind of improve the sentiment analysis because they're able to look because they're trained in like a more complex way, like for transformings and embeddings than like your basic sentiment analysis model would be. They're able to look at a little bit more complexity. I would say that like what we gave it, like we're kind of like medium complexity because they were like paragraphs or a few sentences, but like not like very long essays or even like a one pager of information. Okay. I hope that answered it. Now that we're 40 minutes in, I'm going to move over to the third part of today's sentiment analysis walkthrough. I'm going to copy this up here. So we have results from basic sentiment analysis, and then copy this up here, just because the third part is going to take a little bit longer to implement, and I want to make sure that we get through it in our stream time. So we're going to go over to our IPython file. This is a Jupyter notebook. Jupyter notebook just kind of helps you run things in a more like segmented way, so it's easier to see where errors are coming from, and with very heavy output things like this, it's a little bit just easier to walk through everything. Okay, so we're going to walk through a little bit of this, and just for reference, I followed this tutorial, and then I am applying it to the restaurant reviews. So I'm going to have this pulled up just if we run into any issues, and also if you would like to read through everything later. So we're going to be building our own sentiment analysis model. You're able to do it without code if you want to do that on your own later with auto NLP, but we'll be using transformers for this. So let's get started. So first, we're going to import some libraries. Okay. We're going to enable Jupyter. Okay, Python. Okay, we'll just use the existing. Okay, no, we're just going to use Python that is here. Beautiful. Okay. Okay, and then so right here, this is not the right page. Right here, we're just importing one of our libraries, and then we're checking to see if CUDA is available. And this is if we can use GPUs, which is just like a faster way for us to process like when we're running the models, than if we would be able to with CPUs. That's why it's saying false. You don't need to worry about the rest of the process. It just means that it's going to be running a little bit slower than if we were able to use GPUs right here. We're going to install transformers from Hugging Face, as well as data sets, and a few other kind of like basic housekeeping libraries. These are all like lines of code that were already in the GitHub repository when I pushed it. So you should already have this, and you should be able to run it on your own. If you run into minor issues or have questions, feel free to send them in the chat. We won't be able to spend much time debugging like individual issues, but if you have any questions like on things, or like everyone is running into an issue, I'd be glad to help run through all of that. Okay, so let's get started with actually building it out. So for the first step, I have already done this in the file, so you're able to see the CSV. But if you're curious on how to convert it from a TSV to a CSV, we're going to do that real quick. It's pretty simple. I was unfamiliar on how to do that before I was doing the research for this stream, and I think it's a useful skill for y'all to have. So let's get started with that. We're going to import pandas, which, if you're unfamiliar, is just another library for machine learning and data processing in Python. And then we're going to set our data file to be equal to restaurantreviews.tsv. There we go. Now it's finding it. And then after we do that, it's pretty simple. We just need to read in the data as a table in Pandas. And then what we're going to do for reading it in as a table is find the separator as a on each new line, which in TSV files is a /t. Oh no, that's not what I want. Okay, we're gonna go to, I accidentally refreshed the code space page, so I need to find that again. Okay, so here we have our code space. My bad. It's loading again. My apologies. That's the one downside with code spaces if you accidentally refresh the page. I'm gonna open it back up. Okay, and I think I'll need to rerun some of this because, oh no, it looks like it's still here. Sometimes the Python, like the memory in the notebook can get a little bit wonky, but it looks like because it was just a second ago, it's still here. So I'm gonna have, I don't need to see the port. We're gonna create our kind of like sitting CSV file. We're gonna do pandas dot read table, and we're going to read in our data, and then we're going to do a, I think it's, no, it's the other slash. So this is for new lines in our TSV files, and we need to declare that as a separator. Otherwise, read table is not going to know what to do with it. And then we are going to actually create this as a CSV file. I'm going to run this and see if we actually have pandas. Okay. This looks like a warning, so we're going to let it for now. 2 hours. We do not have time for a warning right now. Okay. So now we're actually going to convert this to a CSV now that we've read it as a table. It's pretty simple. So we're going to write it as restaurantreviews.csv, and then I'm going to delete this file right here in the browser so you can see it's actually creating it when we run this code. So being delete. Okay. We're going to delete it. Don't worry, because it'll be back in just a second. Do restaurantreviews.csv. And then for the second, we're going to set our index equal to false. This will just make processing our data a little bit easier later. And then we are going to run it. Here we go. Now we can see that our, or no. Oh yeah, it was. So it was deleted, and now it looks like it's back. I'm gonna run this one more time just to make sure this file is, or this code is working as I intended it to. Yep, okay. And now it's been recreated. Okay. Beautiful. Okay, so now that we have converted it to a CSV for our main data set from Kaggle, we're going to need to actually start to load in our data set into our program. So we need to load it in as a CSV. So we'll need to import some libraries for this. We'll do this by from datasets import, and we're going to be importing load dataset. And then after that, we're going to set our dataset equal to load dataset, and then we will do our .csv as the file type, and then the data files are going to be equal to restaurant reviews.csv. And then I'm going to just print out our data set to make sure that everything's working. Oh, we have an error. Got an unexpected key. Oh, because I forgot an underscore. It's always the little things. There we go. Okay, so we have our data set, and right now we are generating the train split as 100 examples. We're going to split this into train and test in just a second, just because you need to have a certain number of data points to train your data set as well as test it to make sure it's accurate. We want to see that we're having a high level of accuracy before running this on our Bleecker Street reviews, just to make sure it's not like a 20% accuracy. It would be very bad accuracy. Luckily for you, I did go through this beforehand, so we should be having a much higher accuracy than that when we actually complete this. So we're going to do that by creating a train segment and a test segment. And we do this just by creating some small variables. So we're going to have our train segment, and that is going to be equal to just our data set at train. And because the entirety of our data set is at train, we'll just be accessing it like this. For more complex data sets on Kaggle and elsewhere, they will already have a segmentation of test and train, but because everything is train from the get-go, like we'll just need to do train and train to create the two, but normally you're able to do it in like a more straightforward way. And then what we're going to do is we're going to shuffle them around so that we're not getting everything back to back. Set the seed equal to 42. And then the next thing we're going to do is we're going to select our actual values after we shuffle them. And for our train segment, we want it to be much larger than our test segment. A good general rule of thumb is for your test segment to be 1/10 of the size of your train segment. So we're going to do that here. So in this case, what we're going to do, I think, is have 750 for our train, and then maybe 75 for our test. We could do it a little bit larger, but I feel like this is a good amount for the size of the data. So we'll do this by doing I for I in range. And the range is going to just be 750 because we want 750 train data points in our segment. And then for a test segment, we will also use our dataset library, train, and then we'll shuffle them again, just because we don't want to have everything, like we don't want to just take the first 750 off the top and make those the train, and then take the next 75 and make them test. The randomization or shuffling of the data makes it a little bit better, just because sometimes not all data sets are shuffled properly, or you could have a lot of positives in a row and then all the negatives at the end. So this helps to kind of proactively take care of that. So we're going to do something simpler here. We're going to do I for I in range, but our range is going to be different here. What we're going to have is we're going to start at 750, and we're going to end at 825, just because we're going to have 25. And we want to make sure we're getting different values than here. Okay, we're going to run this. Beautiful. Let's maybe print out so we can make sure we're getting the right train and test segments. Beautiful. So we have 75 and 750. Cool. It looks like someone asked, is it correct that we have features reviewed, liked as a value? Is there any parsing error? No, that's correct. And what we should be having for our like different values. So reviewed liked is kind of like whether or not they liked it. That's kind of like the Boolean, like true false for the sentiment analysis of a review. We want to see if like they liked it or did not like it. And the values we're receiving here, you see how it says liked in this column? That is the value. So review liked is just like the different values. Yeah. Okay, glad that makes sense. Beautiful. Okay, so I'm gonna get some water and then we can move on. So we're going to be using Distilbert to help create our model. Distilbert is just going to essentially help with our sentiment analysis. It's going to base it off of our data, but it is like a basic sentiment analysis model. It kind of gives us the skeleton, and we're adding in some meat with our different reviews and data to turn it on. So we're going to need to do some more imports. So from transformers, we're going to import our auto tokenizer, and we're going to set our tokenizer, not tokenizer, and we're going to set that equal to our auto tokenizer library, and then we're going to call our from pre-trained argument, and the pre-trained argument we're going to use is Distilbert. There's more information on what Distilbert is overall in the Hugging Face article I linked in the README, but we're not going to go through that right now. All right. We're going to run this and see that everything is going okay. Okay, it looks like that's all going well. Awesome. So now we are going to pre-process everything with our examples. So I'm going to go down here. Yeah, okay. So we are following this section right here. And we are going to create just a basic function. It's going to be our pre-process function, all our examples, and then we're going to return our tokenizer, and then we're going to call the examples we put in as our data, and then within that, we're going to go to review, because we have our review as our index, and then we're going to set truncation equal to true. Okay. And then we are going to map our tokenized train and test. And we're going to have that be equal to these values right here. Train segment, test segment. And we're going to just map those to our function. Pre-process function. Pre-process function. Okay. And then we're also going to set batch to equal to true. Okay, we're getting an error. Review. Okay. Okay, I'm gonna look at this and see if I maybe converted it incorrectly. Okay. Because they were doing a something for tweets, and I was mapping it to our specific data set, so things are a little bit different between the two. Oh no, 404 error. Okay. Maybe you were right earlier, and this is parsing error. Let me look and see. This should be. Oh, this might be. I think this might be a parsing error. Okay, so I'm just gonna print out CSV. Okay, yes, okay. And then in TSV, I think it's just a long space. Wait, no. I guess it's just gonna be new line. No, okay. Okay, it looks like it's reading it properly. I think it's because there was a space earlier instead of just having the new line file, and like that's why it wasn't parsing it properly. So whoever asked about the parsing error earlier, I was wrong. I think that was actually an error. And if you were following along and want to fix it, you'll just fix it by making sure that there's no spaces in the separator. So that just means I need to rerun these. Yes, okay, so now the features are separated. Sorry, a little bit. Yeah, made a mistake earlier. See if that, yeah, that fixed it. They're being correctly mapped to everything. So now we can move on. It's always the tiniest little things. Okay. Thank you for catching that earlier, even though I did not think it was an error just yet. All right, so now that we have mapped everything and pre-processed it for tokenizing everything into train and test, the next thing that we're going to do is actually work on collating the different data. and we'll be importing some more as well. So what we're going to be doing is we're going to import from transformers, and we're going to import our data color letter with padding, and then we're going to set our data color letter. I'm just going to copy and paste these in, make sure everything's running properly so we can get moving. All right, that looks like that's running properly. And the next thing we need to do is import an auto model for our sequence classification. These are just different libraries that we'll be using so that we can actually train our model. Okay, and then I'll be copying in our actual model with Distilbert. Again, if you want to know more about like the skeletons behind all of this, you can go to the article I linked after this, but I want to make sure that we're actually getting some output by the end of our stream. Okay. Some weights were not initialized. Classifier bias, weight, pre-classifier, weight, and bias. Okay. This is just to make it more accurate for right now, and our purposes, this is okay to ignore for the time being. But if you want to do anything that is a little bit more complicated, will be used on more real-world applications and not just to create fun art and kind of like as a learning exercise for sentiment analysis, you want to include those. They will just take a little bit longer. Okay, so next thing we need to do is import some information so we're able to actually compute our metrics and load our accuracy, our F1, and as well as our predictions and everything. Okay, so I'm gonna bring in some import statements before we type out a new function to actually be able to compute our metrics. So run those. It's installing a new library. Looks like that was all successful. Beautiful. Now we can move on. So next thing we need to do is create our compute metrics. So our compute metrics function. We're going to take in our valuation and prediction. And then within that, we're going to load in our accuracy as well as our F1. So we're able to actually predict our accuracy and F1 values. So we can see the accuracy that we'll be creating our gradient on. So tab, loading our accuracy and loading our F1. And so for both of these, we're going to be using the evaluate library that we imported but aren't using just yet. Right here, evaluate. And then we're going to be calling loading. So we can do accuracy. I spelled that horribly wrong. My bad. And then we're going to load in our F1. Load. And then we're going to load in F1. Beautiful. Okay. The next part, we're going to actually do our evaluation prediction. We're going to get our logics and our labels. And then we're going to actually do our predictions. And we're going to call our NumPy library, which we imported up here. That's also a pretty popular data processing and machine learning library in Python. And use the argmax argument. And then we are going to put in our logics variable. And we're going to set the axes equal to -1. And then after that, we're going to do something similar for our accuracy as well as our F1. we'll have accuracy. This is spelled wrong. Well, maybe it's spelled wrong. I don't know. Maybe no, we're just not typing after it. And then after that, we'll be doing MP, or no, taking our load accuracy, and then for F1, load F1, and then we're going to actually be computing our predictions. And then some other information we need is our references. And then for our F1, so we'll be actually calling accuracy. Here we have compute as well. We're going to be doing something very similar, actually the exact same, but this is just F1 instead of accuracy. Awesome. And then we just want to return our accuracy in F1 so that we can see that it is properly running. Return accuracy, and then maybe like a new line, and then F1 is F1. Awesome. Oh, nice. So we will be using this in just a second once we actually log in to Hugging Face. So we're going to log into Hugging Face like this. If you don't already have what are we missing? Okay, I need to install iPi widgets. Fun. Okay, well, let's try this again. Beautiful. I don't know if Okay, in the past, it's given me a pop-up to add my Hugging Face login, so this might be an error. We will see later. But now we need to actually go in and import some more stuff and add our training model. I've actually found a sentiment model off of Hugging Face that we're going to use. And if you're unfamiliar on Hugging Face, you're able to create user access tokens. You can actually run everything. It's low cost or free for most things. I'll be deleting this after this stream for the user token, but that's kind of like how it like interacts with the login information, which I'm not sure why that's not popping up just yet, but we'll cross that bridge in just a second. We're going to add some basic training arguments, and I will talk through these in just a second. These are kind of basic ones that are boilerplate, and I just want to make sure we have time to do the actual art. So I don't know why it's yelling at me here. Non-indent, not expected. Maybe, there we go. Do we have any questions in the meantime while all of this is running? Okay. Looks like everything's fine. Tammy asked what the evaluation data set is. That's just the data set we use to actually evaluate our model to make sure it's running properly. Yeah, which was done in our tokenized test. Tokenized test is the test values we tokenized earlier from our initial food reviews. Yeah, I can talk through all of this now that it's running. So we have our import statements, the repo for our fine-tuning sentiment analysis, as well as we have our training arguments for actually training the model. So we have where the output is going to go. I think we need to put an actual repo in here, and that might be why it's taking so long. We'll see in just a second. How fast it's learning. These are for how fast it's going to go, like for the batch size, how many values are we're training in each batch for the training, and then in the actual trainer is when we're running the model with our actual arguments to make sure it's doing it on food reviews and not just other data. So we have our model that we or no, okay. I spaced for a second. And I realized I said we might need to put an actual repo in here, but we have the actual repo, which is from this. Okay. Sorry about that. But we have our model that we're running our trainer on. The arguments we're taking in is all of this. So these kind of fine-tuning specific information. And then we have our specific training data set, as well as our testing data set, which is also known as evaluation. Evaluation and test are kind of used interchangeably for this. Our tokenizer, which we built up here. A lot of these are kind of just importing different libraries and calling functions. You don't need to know the mechanics behind all of those, but just how to kind of access the function. And then our data correlator. We have our compute metrics right here, which is calling this function. I'm not sure. I guess it's taking so long because it's running the model and installing this. In the meantime, while this is running, I'm going to start walking through our gradient overlay. I'm going to do that with some images from the Bleecker Street Pizza with the sentiment analysis we did at a more basic level earlier. And then we can kind of see the different images. So here we have our index.html. And I'm going to open that really quickly. In the browser as well. So this is what it looks like right now. It has the Geeks for Geeks logo because this is where I took the gradient overlay example from and then kind of added some custom colors. we're going to add some custom colors to ours as well. So right here, you can see this. I have a pink and a purple, but if I comment these out, the gradient is going to go away, or this will cause errors, one of the two. And we'll refresh this page. And you can see it's completely gone, so that's not what I should have done. I'm just going to take the class away. Cool. Okay. I'm going to refresh this page. And we can just see it says, this is my background. So it's taking away the entirety of this style. We add it back and we get our overlay. I'm just going to get rid of, I guess, this entire thing, the linear gradient. To show you like what it normally looks like. Here we go. So like we have the like normal Geeks for Geeks logo, and you just add back the gradient and you get back all the colors. For the sake of time, I'm just going to keep our current colors for the gradient. But we're going to find some basic pictures of Bleecker Street Pizza for this. So I'm going to do it from our original reviews we had, which we have right here. So I'm going to search for champions. I think that's going to be most relevant. Yeah. So I'll just take this picture and I'm going to copy the image and then I'll just paste it into our repository here. And this is going to be rename 1. And then in our index file, we're going to have this be 1.png instead of the initial one. And I'm going to get rid of the text just because I feel like it's kind of distracting. Or no, maybe this will be the fun art we do. I'm going to take the initial review and we're going to overlay the picture over that. Here we go. Okay. This should be good for right now. And then bring it over here so y'all can actually see it. Okay. We're getting the actual review and the gradient, but we're not getting the image. So let's see what's going on here. URL 1.png. It's not a URL, it's actually local. So I need to put some different information. We just need 1.png. Okay, let's see. Okay, and then we will refresh. Oh, okay. Gradient's gone. Oh, okay. Okay, I realize what's going on. Let me explain. So, copy image. This is a download issue. Okay, so let me try this real quick. There we go. Okay. Can y'all see my screen now where it has overlaid the image? The issue was that the index.html screen I had pulled up was a local, it was a local version of it that I was running in VS Code, and I didn't copy over the image properly. I'm just going to use the URL from Google Images for the sake of time now. But here is our basic art. We have our food review overlaid over the image of the pizza, and then we added our gradient. The one other thing that we might do later is adjust, actually adjust it to the percentage of the gradient. But let's look back at our IPy file and see if it's running. Looks like it's still running, so our model is still training. So let's go back and we can add some more images. So I'm going to make some new div classes. We can have 3 different pieces of the art. Yeah, and then I'll just have this be, instead of overlay, I'll just have it be 1. We'll have, oh, I can't have numbers in classes. That's my bad. We'll do 1 spelled out. And then I'm going to copy all of this. The only difference for the different classes is going to be just the image itself. We'll have this, and it will be 3. So 1, going to delete the old review, and this will be 2. And then that's not the right thing. And this is going to be 3. I'm going to bring over our reviews. I can remove that just a second. Okay, so we're going to remove these last quotation marks. Let's see. Yep, okay. Quotation marks have been removed. Oh, I accidentally copied over the third. That's convenient because now I can just, there we go. Okay. And then put this down here. We haven't changed the images yet, but I just want to make sure that like all of this is working properly. So let me bring it over to the local version so y'all can see what we're working with. Oh no, not this again. It's been saved. All right, what's going on? All the images aren't popping up. Okay. We have 1, 2, 3. Oh. No. Save. Okay. I'll add some breaks and then we'll see what the issue is. Okay. Oh, I see. I made a silly mistake when copying it over. I forgot to copy the link. So let's see if this works. There we go. Okay, so now we're going to get our second review. So our second review right here, I came to try the Nona Maria. I think that was the second review. X out of this. And then go back. Okay, yes. So we'll do this one for our second picture. So I'm just going to go into our index file. And then right here, the initial mistake I had made is I did not change this to be the like actual URL. I was still trying to have it be locally, which is a possibility. I just don't want to copy everything over right now. So this will be a little bit faster for us. And this will go right here. No, that's just an indent error. Okay. And then lastly, our third review on a corner of Bleecker Street. You can choose Euphoria. Okay, so this is a okay, so it's positive, so we need to go to our positive reviews to find it. I maybe should have gotten images and the reviews at the same time, but well, okay. I'm just going to choose a random one just so we can get this going a little bit faster. We'll choose this picture. I don't like that one actually. We'll do this, the iconic outside view, not just the cyan. Okay, and then we'll copy that into our URL right here. So URL, and copy this in, and then I'll bring this over so y'all are able to see what it looks like. Nice. And then refresh this page. Nice. So we have our art. Yeah, as you can see, it's not perfectly cropped. And because the reviews are kind of long, the pictures aren't as big as maybe like we would have thought, or like you would want to see. You can like maybe position them to be like a little bit better. I think instead of doing the manual adjustment to see all of the pictures, I'll just make the pictures a little bit longer so you can see more information. But I like how it's looking so good so far. I think this is a cool like sentiment analysis based art piece. Okay. So yeah, we'll just have the height instead of being 280 pixels. I don't know. We'll do like 350 pixels. No, not 2350. That'd be way too big. There we go. So just copy this for all of them so they're all uniform. So we have a even gallery wall for our digital art gallery. It's done locally, and I'll show you what I changed in the version that y'all can see in just a second. Okay, so we're just going to change these to be 350, 350, and 350. Okay, and then we'll refresh our page. And you can see it's a little bit bigger. You can see more of the pizza, more of this. I don't like this last image. It's not really showing a lot, so I'm just going to find one that you can see more in. Even though I like this picture overall, and if we maybe had more time together, I'd crop it. Let's do this one. I like this one. It'll be just a little bit of a better art piece. And then hopefully our model is done training. And then bring this over to the local version and refresh the page. Beautiful. This review is so long. I'm gonna choose a shorter review. These are like very nitpicky, but like it's, I don't know, like for the fun part of this. We'll do this one. And we'll copy it in right here. Beautiful. Okay. And then we're going to refresh our page one more time. Nice. Okay. Shorter review. You can see more of the this, and we're getting our gradient overlay. I think the gradient overlay is honestly working pretty well for the pictures. It's kind of giving it like a fun filter. I don't know what y'all think, but I personally like how it's making the art look. We can maybe change the font later, but let's look back at the actual sentiment analysis, what y'all came here for, in addition to the art, of course. All right. So let's see where we are. It's still loading. Yeah. I guess not having GPUs is really making a difference. So yeah, I guess we'll just continue working the art. If it's not done loading by the end of our session, which fingers crossed, within another 20 minutes, it should be done. I'll have all the code and like the resources I followed up above, so you're able to kind of like follow making your own sentiment analysis fully. But fingers crossed in like about 5 minutes or so, it's done. Because everything is, I don't know like why else it would be running so long? Maybe I don't want to interrupt it though, is the thing. I'll give it another 5 minutes while we continue tinkering with our art. I'm going to change the font because I think the default one is ugly, and this is supposed to be artistic after all. So I'm going to go to Google Fonts, and we are going to pick out some fun fonts together for our art installation or digital art. It's not necessarily an installation, it's just us messing around with the stuff, I guess. We could do, because that's a review and not just one word, I don't think any of these would be good. We can maybe use like one of these for like a title. I don't know how I feel about that one for the title. Let's do that just like this one for the main like text. I feel like it's fun enough, but also basic that like you can still read it. If you disagree, you can change the font in your local version. Yeah, okay. So, and if also like if you haven't used Google Fonts before, it's pretty easy to import it. So you just copy this over to your CSS, which we have right here. You just import it from Google Fonts, and it basically tells you everything else to do. Yeah, I don't want the bold one. Oh, it's because. Got it. Okay, we'll get trash this. Let me refresh the page. That was one I was using when I was working on a different project. Okay, so copy this over again, and then go to our index file. Copy this in. Gotta tab it properly just for readability, not because it's Python, because it's HTML. And then we're going to actually make a CSS style. Beautiful. Okay, very easy. We don't need all of this actually. This is if you're going to use the same font and have like a bold and like a heavier weighted version. I don't really think we need to do all of that for this purpose. So I'm just going to have the body have our text face be equal to this. So we just need the font family. Okay, we're gonna, yeah, that should work. And then bring it over so y'all can see it. My computer's a little bit slow right now, which I'm assuming is because the model is running. And I have just a few tabs open. There we go. The font changed. I kind of think the white is a little hard to read. So we can change that in a second if the model hasn't fully executed. But it looks better than it did before, and that's what matters. Okay, let's get rid of all these pictures. Just closing out some tabs. I don't need the font face anymore. Close this out, and let's see what's happening in our Jupyter Notebook file. Okay, this is still running, which makes me feel as though maybe it's something to do with the pip install, just because it's already been, I think, close to at least 20, 15, maybe 20 minutes. I'm gonna copy this and just try running this in one file or in one cell and then run the other code and then just kind of see if we're getting errors with this. And maybe that's what's like causing it to run forever, and then we can proceed. Wait, is it this? I think it's the percent sign. My apologies, y'all. I think I just included the wrong executable. Yeah, that was it. No, it's still running. I guess just pip is taking forever to install this. At this point, I am just going to walk y'all through the rest of like how we would apply the tutorial since we have a little bit under 15 minutes left. Sorry we weren't able to properly execute it in Jupyter Notebook, but I want to make sure you at least get an idea of how building out your own sentiment analysis could go. But I hope you enjoyed learning like actively for the rest of it, but we'll just kind of walk through what it's supposed to be doing. So you can see we did the pre-process function. This was supposed to speed up training, which wasn't working properly. And then what the code we had written out was supposed to be training the model. So we had the information for training the model, defining the metrics to evaluate and fine tune our model, which we had earlier with the accuracy in F1. This is where we logged into our Hugging Face account. If you want to create a Hugging Face account, they're free. So you can just create one on your own and create your own key. It's easy to put into the code or log in with the pop-up. And then after that, we need to, like what we were working on before, I guess the last cell that ran successfully was training our model. We defined all of our arguments and a trainer with everything we had constructed or worked on up to that point. We had a repo name, all the training arguments, like specifying the information, actually training the model. And then we needed to fine tune the sentiment analysis and actually train it to have like our final Dilbert model. So we were really close, like on the last cell right here. We were working on the training and fine-tuning arguments. I'm gonna just paste over this last argument or these last two arguments into cells in the IPython file, just so y'all have them. I know they're gonna be on the walkthrough article as well, but I just want to make sure you have them easily accessible. So if you want to go back and look at it after the fact, you are able to, which as we were talking about like learning earlier and like good ways to get involved, making sure you like look back at this stuff and kind of tinker with it on your own, making sure you're taking an active role in your like overall like learning process. Okay. So yeah, we'll bring over these and then I'll add any changes we need to like apply it to our actual model, the trainer, and all of that is the same just because it was like defining it, but the actual data set is different. And of course, like how we, because like the example was using it for tweets. So like the only difference was that they were using a different data set and the data set had a pre-built-in test segmentation. Okay. Yes. Okay. So, and then here is the testing. And then instead of having these, we're going to do it on our Bleecker Street reviews. It's a similar process for like how it like spits out information. So as you can see, it'll have like the label on like the actual data of if it's negative or positive. So 1 would be positive, 0 is negative, and then how certain it is a score of like 95 to 94. But like that, like the prediction is built off of our food review data instead of like movie reviews or tweets. Okay, and then I think Bleecker Straight Reviews isn't actually in our IPython file, so I'm just going to copy that over. So we'll have, I think, I'll just put it up here. All right. Sentiment model, Bleecker Straight Reviews. Just declared up there, so that's like why it's not. Oh no, because I did not. It is just street shortened. Again, always check how you spell things and like the underscores. It's always little things in my experience that lead to mistakes. Cool. Okay, so this will end up printing out this after you're successfully able to train it, which I think it's just the like CPUs versus GPUs. It means it's taking a long time. Our data set isn't that large, but I think like it's just taking a while because of the processing power. Okay. So that is a basic overview of kind of like what the rest would be like. So we can see what it's like. This article too shows you how to do this without code with like auto NLP. If you just like want to work on sentiment analysis without going through all of the coding, or you're getting frustrated by errors, and maybe like want to work on something like this a little bit longer, you're able to do that. Now that we're getting at the 5-minute mark, I'm going to switch back over to my slides and allow for any questions that y'all have, and we can do some last basic housekeeping. But thank y'all for joining. It's been a pleasure to have y'all here with me. I definitely learned some more about sentiment analysis. I learned a little bit more about gradients, and I think it's fun to kind of combine both machine learning and web development. Those are like two of my like favorite niches within tech to learn about, and I also like using technology for creative purposes. I love like digital art, so I feel like this is a great way to combine a lot of different interests. I hope you all learned something and had fun with me. Be sure to check out the rest of the Global Hack Week data streams. Drop any questions you have for me in the chat. I'll stick around to answer those. And if you popped in midway through the session, you can register for this event on Global Hack Week through MLH at the link on the screen. I'll paste that in the chat again as well, just so that you are able to do that. And then I'm also going to paste in the chat a bit.ly link so you're able to access the slides that have a link to the code we went through. And I'm going to push everything to GitHub after the stream is over, so don't worry about that. All right, so here is the MLH registration link for this event. Be sure to register so you get your attendance points for today. I don't know what swag items in particular or what different like rewards MLH is giving out, but be sure to register your attendance. Yeah, any questions, feel free to ask, but I'll also paste in the link to the slides. So the link to the slides, I'm just going to put it up as a quick little banner. Oh, not that. It's just going to be bit.ly/GHW-0914. That's where you can access the slides, which will have the link to the code, and I will push everything at the end. I'm going to stay on for a few more minutes to answer any questions y'all may have, but thank you for joining me. All right. I don't think there's any questions as of now. Have a great rest of your Global Hack Week. Hope you learned something and have a great rest of your Sunday. Good night.